Hello students, I am Ravi Sir. Here we have the session of AE exam. The important questions of AE exam we have to see. This is the most expected question. But in this lecture, there is a revision of 3 chapters. You can see that for the production, already the one session is completed and weightage and all the things are already said by my colleague Madhushekar sir. You can go there and check the weightage, right? Now see in this session how many chapters I am going to cover. You can see that. Just see here the methods of manufacturing process. This is your syllabus, and in that syllabus you can see that the foundry is one of the topic, means it is a metal casting. After foundry we can go with the welding, soldering and brazing. Yes, and after then we have to see very important modern manufacturing process. Also we can say as non-traditional machining methods, and that all the methods are here, it is mentioned. That all the topics we have to see in the today's lecture. Now see, I am going to cover here the 3 topic. For the casting I come with around 15 question. For the welding also the 15 question, and for the non-traditional machining method, very small topic, then I come with the 10 questions, right. Now you can see that the total 40 question, but here you will not get only the 40 questions. With the help of these 40 questions, there will be the revision of all 3 topics within the 1 hour, 60 minute 40 question. Now we have to start one by one. Now see, I want to start with first non-traditional machining method chapter. Every time I am starting with the casting, then welding, then NTMM. But in this lecture, I want to start with directly NTMM. Now see the first question of NTM. Before the first question, you can see that in the non-traditional machining methods, you can see that the 7 methods are there. Out of 7 methods, the first 6 are more important, and the chemical machining rarely asked in the exam. But we'll see all the 10 questions on this all methods. Now see the first question. Which of the following is thermoelectric process? What is the question? Which of the following is thermoelectric process? Means what? Electric energy we need to supply. The power we need to supply. And there is a thermal effect. Now you can see that the electrochemical grinding. This is the electric, but it is a chemical, not a thermo. Heat is not going to develop. The large amount of heat is not going to develop, then it is not correct answer. In the abrasive jet machining, large amount of heat is not going to produce. Electron beam machining, 100% correct. This is the thermoelectric process, that is the electron beam machining. Right. Then ultrasonic machining, no, this is not answer. Then, which of the following is thermoelectric process? Electron beam machining is there. Electric discharge machining is also there. Laser beam machining is also there. Laser beam machining is also there. Hence correct option is C, but EDM and LBM are also thermoelectric process. Now see next question. Which method is more suitable for machining of ceramic material? Machining of ceramic material. When the ceramic material, we think about the ceramic material, then we can think firstly the ultrasonic machining method. We can think about the ultrasonic machining method, but here only ultrasonic machining method is not the answer. There is abrasive jet machining is also. I am writing AJM, or also we can say abrasive water jet machining also we can say. These are also method. The ultrasonic machining is very, very famous, but just see, is the ultrasonic machining option is there? No. Is AJM, AWJM? No. Then the next method in which we can machine the ceramic material is the laser beam machining. With the help of laser beam machining also, we can work on the ceramic. We can make the hole on the ceramic. Then LBM is also correct answer. And you can also reply me here online. Yes, you reply it here. No need to worry about that. I'm not going to wait for your answer, but it is better to reply if you know. I will see it later. Your replies. Yes? Yes. Now the question is that the laser beam machining, and there is a electron beam machining also. EBM, electron beam machining also. Then in the LBM as well as EBM, we can cut the ceramic material. But most famous is ultrasonic machining, abrasive jet machining. Very few people know that LBM and EBM also machine, also make the holes on the ceramic material. Which method is best for machining deep holes? When there is word deep holes, means there is a L by D ratio. What is the L by D ratio? I am showing here you the L by D ratio. Just check it, what is the L by D ratio? You can see this is the length. You can see this is the diameter. This is the diameter. This is known as L by D ratio. L by D ratio is 20 for EDM, electric discharge machining. But L by D is greater than 20. Only one best method is there. That is electron beam machining, EBM. EBM. This ratio, this length divided by diameter ratio, length divided by diameter is greater than 20 in electron beam machining. Yes, but in the electric discharge machining up to 20 is possible only. Understood? Next. Conducting tool and conducting workpiece is required in. Conducting tool and conducting workpiece is required in. Now you can see that in the laser beam machining, there is no require of conducting workpiece. In the electron beam machining also, there is no any requirement of conducting workpiece. And just I said that the ceramic material, the base in the cup of tea is all made by ceramic material. The tiles are the ceramics. Then is the electricity is traveling through the ceramic? Not possible. Hence that ceramic we can cut by laser beam machining, electron beam machining, ultrasonic machining, abrasive jet machining, abrasive water jet machining method. Right? Then here conducting workpiece, ceramic is not conducting, hence option A and B is not there. Yes? Then ultrasonic machining, here also we are working on the ceramic. But electrochemical machining, conducting tool and conducting workpiece is required. Both very important. The conducting tool and conducting workpiece must required in electrochemical machining. But not only electrochemical machining, out of all 7 methods, electric discharge machining method also requires conducting tool and conducting workpiece. Because the power supply is given to the tool as well as workpiece. Now see here, I come with the diagram of electrochemical machining. Here you can see that workpiece, this is the tool, both are connected to power supply. It means that both are conducting. Yes, this is the diagram of electrochemical machining method. Understood? Now see the next diagram. When the gap between the tool and workpiece, that gap we are going to reduce. This gap, now there is big gap, but we have to reduce the gap. Then we need to give the power supply. The many exams, one question is asked, what is the gap between the workpiece and tool in electrochemical machining method? Just see what is the gap. Gap of 0.10 to 0.60 millimeter. What is the diameter of lead pencil? 0.5 millimeter, 0.7 millimeter. Hence it is a 0.5 millimeter, 0.10 millimeter to 0.60 millimeter. Understood? In that way you can remember that gap is. Yes? And here this is also very important. Hence I am saying that this is not only questions lecture, important question, expected question lecture. This is a revision of the topics. Right? Now the power supply is given to the workpiece as well as tool. This type of shape is formed on the workpiece. This type of shape is going to form on the workpiece. This is the electrochemical machining, both are conducting. And the electrical discharge machining also, both are conducting. Right? This question is over. The correct answer is electrochemical machining. Both tool and workpiece are conducting only in the 2 methods out of 7, ECM and EDM. Now see next. The workpiece and electrode are separated by a gap. Yes, called spark gap. Oh, where the spark is going to happen? Where the spark is going to happen? In which method out of 7 the spark is there? Tell me fast. There is only one EDM, electric discharge machining. Electric discharge means electric spark, discharge means spark. Out of all the 7 methods, there is only EDM method where the spark is going to occur. Understood? Right. Then the spark is going to occur in a gap, and what is that gap? Means what is that spark gap? What is that spark gap? Yes, very, very small. Just see, this is the diagram of EDM. I taken this diagram from the groover. What is this gap? Spark gap. Very small, beyond our imagination. And that gap is 0.020 to 0.05. Answer is option A. Very, very small gap is there. Understood? You can also respond here. You can also give the answer. Oh, many students are giving answer, and I am very, very happy. Very happy, very happy. Okay, Akhil, thanks. Yes. Now see next question. In ultrasonic machining method, USM tool vibrates at a frequency of, what is the frequency in ultrasonic machining method? Why the name is given ultrasonic? Because the ultrasonic means supersonic. What is the supersonic frequency? It is around greater than 20 kilohertz. Yes, greater than 20 kilohertz. But correct answer is, in ultrasonic machining method, the tool vibrates at 15 kilohertz to 25 kilohertz. Tool vibrates at. Right? Just see here one diagram. This also I taken from a groover book, manufacturing. You can see that the tool is vibrating here continuously. The tool is vibrating, going up and down continuously. You can see that these are the abrasive particles. These are the abrasive particles. And what are the question they asked? Vibrates at a frequency at. What is the frequency of this vibration? That is up down. What is the frequency? It is the 20 kilohertz to 25 kilohertz. Then I can see that 20 kilohertz means 20 into 10 raised to 3 hertz. 20 into 10 raised to 3 hertz means 20,000 hertz. Hertz means what? Cycle per second. Means tool is vibrating 20,000 times per second, beyond our imagination. And that's why the name of this chapter is non-traditional machining methods. These are not old methods. These are not traditional methods. And that's why you can see that the tool is going to vibrate. This tool is going down and up 1 time, 2 times, 3 times, 4 times, 5 times, 20,000 times in 1 second, beyond our imagination, right? Then answer is this, 15 kilohertz to 25 kilohertz is the correct answer. Yes, very nice question. Is mainly used, which machining is mainly used out of that all? In machining hard, heat resisting alloys, for cutting cavities in forging dies, drilling holes, machining of complex external shape of turbine blades. When there is a word of turbine blades, complex shape of blades are there, and that complex shapes of blade cannot be manufactured by any method. Out of 7, only one method where we can manufacture that, and that is known as electrochemical machining method. This sentence is not that simple. Firstly, what we think, hard heat resisting alloys, hard material, forging dies, the connecting rod is made by forging method, which has very high strength, high hardness, which can be cut by electric discharge machining method. Hence, when we are going to see that sentence, it is little bit confusing. But whenever the word comes, complex shape, turbine blades, no any other solution. Only one solution is there, electrochemical machining. Hence, the correct answer is option B, electrochemical machining process. Complex shaped component we can manufacture by electrochemical machining, such as turbine blades. Turbine blades and the aeroplane components, machining tungsten carbide parts and nozzle of alloy steels, right? Now see next. Mechanism of material removal in chemical machining. Rarely asked topic, chemical machining. But in the chemical machining, the mechanism is etching. Mechanism is what? Etching. Etching is the mechanism. Melting and vaporization mechanism, where that melting and vaporization there. Melt the workpiece and convert into vapor in the electric discharge machining method, in the laser beam machining method, in the electron beam machining method. Brittle fracturing, where the brittle fracturing guys, ultrasonic machining method. Here also I will write EDM. This is very, very important. Mechanism of material removal is very, very important. Melting and vaporization, EDM, laser beam machining, electron beam machining, very, very important. Brittle fracture in ultrasonic machining method, abrasive jet machining method, water jet machining method, iron displacement, electrochemical machining method, ECM, very, very important question. And etching is what? Chemical machining. Chemical machining, very, very important. All the 7 methods I mentioned here in this question. Yes? Then how the etching, just spray some chemical here on that part. Here we have to remove this material. We have to remove this material. Then spray some chemical on that. Then what happened? The small particles of this workpiece is started removing from there. And after removing, then we can get here the component where the material is removed like that. Just see, if we have to remove this material, then simple we can spray some chemical on that. Then there is etching, and because of etching, the material removal will be there. The material removal will be there. Yes. See next question. Which of the following statement is correct for unconventional machining process? Unconventional means non-traditional machining process. Which of the following statement is correct? They are not asking about wrong statement. They are asking about the correct statement. Means whatever the options are given, out of 4, the 3 options are wrong. Now select the wrong option first. Tool material need to be harder than workpiece. This is not a metal cutting. This is not a tool on which where we are working on lathe machine. Whatever the tool we are using on lathe machine, that tool must be harder than workpiece. That is a traditional machining. This is the non-traditional machining. Tool material need to be harder. Wrong. Tool material need not be harder than workpiece. B. Tool is in contact with the job. No. In the lathe machine, milling machine, drilling machine, the tool is in contact with the workpiece. In the traditional machining method, the tool is in contact with the workpiece. But here, in NTMM, non-traditional machining method, tool is in never contact with the workpiece. Remember this. Non-traditional machining method, tool is in never contact with the workpiece. Yes? Here they are saying tool is in contact with the workpiece. Very soft materials such as rubber cannot be machined. Rubber can be machined with abrasive water jet machining. This sentence is also wrong. Next, super alloys can be machined, and they made by a group of nickel, iron nickel and cobalt alloys. Super alloys are very, very high hardness, very high strength, and that we can machine by number of non-traditional machining methods. Yes. Now see the last question of this chapter, question number 10. In electrochemical machining process, MRR is inversely proportional to. What is the formula in electrochemical machining process? MRR, AI by ZF, AI by ZF. Then MRR is inversely proportional to the Z is valency and F is Faraday's law of constant, Faraday's constant. Then they are saying inversely, the MRR is inversely. Here you can see that MRR is directly proportional to capital A. What is capital A? Gram atomic weight. It is directly proportional to wrong. Current is also directly proportional to wrong. Viscosity, there is no viscosity in that formula, wrong. Density of workpiece, there is no density in this formula, wrong. No, it is correct. How it is? I return the formula for mass MRR, mass material removal rate. Now I will write the formula for volumetric material removal rate. Volumetric MRR. Then what is the formula for volumetric MRR? Same AI by ZF. Then I am writing AI by rho ZF. This MRR is inversely proportional to the density of workpiece material. Is that option is available? Yes. Density of workpiece. MRR is inversely proportional to rho, density of workpiece. And with this, the question and revision of NTMM is over. If you like this, then please message here. Right now we have to start with the questions of welding chapter. Yes? Yes, I am checking your messages here. Okay, many active students are here. And many students will see this lecture after also, after the live session also. Depend on their availability of time, or they make the schedule. We have the number of students, they will watch this lecture later. Okay, fine. Now start with the welding. We completed in 20 minutes. Yes, now we have total 30 questions remaining. 38-minute time is remaining. Yes, our speed is good. Now see second welding chapter. If you like that question, then you can message me. I like this question like that. Huh? You can respond me here. Yes, how is the first question? Which of the following is thermochemical welding process? Thermochemical welding process. Thermochemical. Whatever I am teaching, there is one method. The name of that method is thermite welding. And that thermite welding is exothermic chemical reaction is there. Which reaction? Exothermic chemical reaction. Here what they written? Thermochemical, chemical. Yes, which of the following is the thermochemical? Only the thermite welding. Chemical reaction. Then heat is going to produce because of chemical reaction. Hence this welding is known as thermite welding. This welding is exothermic chemical reaction. Exothermic chemical reaction. Yes, this thermite welding is a fusion welding process. This welding is used for joining the rails. You can see that rail 1 and rail 2. The rails of Indian Railways are joined by thermite welding process. And these two rails are joined here by fusion welding. What is the mean by fusion welding? This material is melting, means rail 1 material is melting, rail 2 material is melting, and by melting that both the joint is produced, right? And this is known as fusion welding. Then thermite welding is one of the fusion welding method where both materials, parent materials are going to melt. Now see next question. Which of the following method does not allow the intergranular mixing of? My God, what is the intergranular mixing? It is the topic of material science. Yes, which of the following method does not allow the intergranular mixing of two metal to be joined? Does not allow the mixing. Intergranular mixing means they are saying does not allow the fusion welding. They are saying does not allow the fusion welding. What is the fusion welding? This material is melting, this material is melting, and both are combined here and the joint is formed. Then what other word is used? Does not allow the intergranular mixing, means not a fusion welding. Gas welding is a fusion welding. Arc welding is a fusion welding. Resistance welding is a fusion welding. Solid state welding is not a fusion welding. Solid state welding is not a fusion welding. Yes, in that solid state welding, these both materials are not melting. Still the joint is produced. Which are that solid state welding process? You can see that the forge welding, friction, ultrasonic, explosive, diffusion, friction welding, friction stir welding, all are solid state welding. I will tell you about the friction welding, how it works, the friction welding, very easy. do the friction like that. Yes, friction like that. Because of friction, you know that the heat is going to generate. Here also heat is going to generate because of friction. Then give the high vibration, then give the high force, the joint will produce. That type of all weldings are there. But this plate material, surface material, this surface material is not melting. Now I don't want to go in detail this topic. Yes. Next, in which of the following method the filler rod used is of different material than the base metal? This is base metal. This is base metal. These two are the parent metals, base metals, and here is one filler rod is there. Here is one filler rod is there, very small diameter rod. Then they are saying that this filler rod material and this base material is a different, then it is known as which welding? Heterogeneous welding. When the parent material and the base, when the filler rod material, this is the filler rod, and the base material is a different, then it is known as heterogeneous welding. When the filler rod material and both the plate material is same, then it is known as homogeneous welding. When the welding can be done without using filler rod, don't use filler rod, don't use this rod, still the welding can be done, and that is known as autogeneous welding. Autogeneous welding. Understood? This question is telling that this parent material, base metal, filler rod metal is different, then it is heterogeneous welding. Correct? Heterogeneous welding. Now see next. The electric arc used for welding purpose is essential needs this ampere current and this voltage. Guys, this is the question of arc welding, but I want to tell you about resistance welding. In the resistance welding, the voltage is less than 10 volt. Also we can say that the voltage is less than 5 volt also we can say. No need to worry about 5 or 10 number. And the current is around 5000 ampere to 20,000 ampere. Such a high current is required in the resistance welding. Voltage is very low. But this is not a case of arc welding. In the arc welding, the current is 300 ampere, 400 ampere, 500 ampere. Yes, 500 ampere are there, very less current is there in the arc welding. Then is there very less current, you can see it here, yes, 500, 600, 1000, 2000 also we can use. Here you can see that the 1000 ampere one current you can see. And the arc welding voltage is equal to 20 volt to, we can say 20 volt or 30 volt also we can use to 70, 80, 90 volt. I am directly writing the big range, say 20 volt to 90 volt. Also we can write the 30 volt to 70 volt. Yes, if in the exam they given the option, what is the voltage in arc welding? One option is 70 volt, one is 90 volt. Then you have to write the 70 is more safe, 90 is at the boundary. If they mention the option 20 volt or 30 volt is more safe, the 20 volt is at boundary. That's why I am writing the all options. Because what happened, the person who is giving the question, he will see somewhere that question in the some book they written the 30 volt to 70 volt, then he will give the option in arc welding 10 volt, 15 volt, 20 volt, 30 volt like that. Then you will see that here sir it is written 20 volt, there is option 20 volt, then give the answer 20 volt. No, 30 volt is more safe, that's why I am writing that all the values. Understood? Then it is a 20 volt is the safe. 5 volt, 5000 current for RW, resistance welding. 5000 20 volt, this is RW, resistance welding, this is arc welding. This is the 1000 ampere in arc welding, it is possible. 5 volt resistance welding, correct option is option B, 1000 ampere current and 20 volt in arc welding. Yes, when the electrode is on the positive pole, it is called, just see the electrode is connected to positive terminal. When the electrode is connected to positive terminal and a workpiece is connected to negative terminal, then it is known as direct current reverse polarity. Direct current reverse polarity. Correct option, reverse polarity. Now what is the direct current straight polarity? When the workpiece is connected to positive terminal, electrode is connected to negative terminal, then it is known as straight polarity. See next. Striking of arc. Oh, striking of arc with electrode is relatively difficult in. Striking of arc means to produce the spark. Where it is difficult to produce the spark, where it is difficult to generate the spark, right? Now see, direct current, in the direct current it is very easy to produce a spark. Either it is a reverse polarity, direct current reverse polarity, either it is a direct current straight polarity. It is very easy to produce a spark, but it is not easy to produce a spark in alternating current high frequency. AC high frequency, it is very difficult to produce a spark. Why it is very difficult to produce the spark here? Because you can see that in the alternating current, here you can see that current is 0. Here the current is 0. Here the current is 0. Yes, here you can see that alternating current, current maximum, current minimum, here the current is 0. When the current is going to stop, then how there is electricity will develop, how the spark will develop, because the current is going to 0, not possible to develop a spark. I don't want to speak in detail here, but when the current is 0, the spark will not produce. Then here the continuous current after each cycle, just see here half cycle the current is going to 0, again half cycle current is going to 0. This is the one cycle. This is the total one cycle. Here at half cycle the current is going to 0. Here the current is going to 0. Where the current is going to 0, the spark will extinguish. The spark will off. Yes. But in the direct current you can see that the current has some value continuously, then current will be there, the spark will be there. And the correct answer is striking of arc means development of arc with electrode is relative to difficulty in alternating current high frequency ACHF. Yes, in welding arc is shielded by inert gas like argon, helium, carbon dioxide or mixture of these gases. Not easy. In gas tungsten arc welding, also known as tungsten inert gas welding, in the TIG we can use the argon. Also we can use the helium, or we can add the both. In TIG, here you can see that argon is also option, helium is also option, but what about the carbon dioxide? The carbon dioxide can't be used in TIG, but we can use the carbon dioxide in metal inert gas welding, means in the MIG, or also it is known as gas metal arc welding. Hence in the MIG, we can use the argon, helium, carbon dioxide or mixture of these gases. Understood? Right. Next. When the continuous fusion zone made up of overlapping nuggets is obtained in the process, overlapping nugget, one nugget is like that, second nugget is like that, third nugget is like that, then which welding? It is known as seam welding. It is known as resistance seam welding. Also we can say the stitch seam welding. I come with some different word, it is also known as stitch seam welding, correct? Next question. Oxygen is filled in the mild steel or alloy steel cylinders. This question is on gas welding. Oxygen is filled in mild steel or alloy steel cylinder of different capacity. Oxygen is filled in the cylinder to a pressure of, at what pressure the oxygen is stored? Here you can see directly answer 125. There, if the 100 and 150 is there, then we can write the 150 also. But general range is 120 kilogram per centimeter square to the 140 is the general range. Some people also saying 120 to 135. These are the ranges. Hence I am writing the correct answer is 125 is the correct answer. Next question. Means oxygen is stored in the mild steel or alloy steel cylinder, means in the oxygen cylinder at a pressure of 125 kilogram per centimeter square. Next, gives a slight case hardening effect on a certain steel. Just see the basic. This iron is very soft material which I like. No, I don't like iron. Yes, because rust is the problem with the iron. That's why I want to mix the carbon in that iron, then we will get steel. Here what they are saying, this gives, which flame gives? Slight case hardening effect on a certain steel. Hardening effect on the steel. If we are adding the carbon, then it will give the hardening effect. Now out of that, when we are using the reducing of flame, or also it is known as carburizing flame. It is also known as carburizing flame. In the reducing or carburizing, same name, the quantity of carbon is more, and because of that quantity of carbon is more, some carbon can mix in the steel. When the small quantity of carbon is added in the iron, then we get low carbon steel. In that low carbon steel, if we are adding the carbon, then medium carbon steel. If we are adding the carbon, then it will be the high carbon steel. Right? Then you can see here, if we are using the reducing or carburizing flame, then we can get the case hardening effect, because here the quantity of carbon is more, and that is very important. In the neutral flame, we can we know that in the neutral flame O2 to C2H2 is same, is equal to 1, but in the oxidizing flame O2 to C2H2 is greater than 1, and in the reducing flame O2 to C2H2 is less than 1. Yes. See, gas welding technique are used primarily for joining the section, preferably less than. In the gas welding, what are the thickness of component we can use? Whether it is 5 millimeter, 25, 50, 75, we are not going for 75 millimeter. There is electro slag welding is available. Submerged arc welding is available. Arc welding is available, arc. The components which can be worked on the gas welding, we can also go with the arc welding. Many components. Right? Now you can see that this is the correct answer. If the thickness is going to increase, if the thickness of plate is more heat is required, and which is not possible to give by the gas welding. Hence, 25 millimeter is okay, then less than 25 millimeter is a good option, correct option. Then in the gas welding, we can weld the plates whose thickness is lesser than 25 millimeter. If the thickness is greater than 25 millimeter, because of more thickness, the more amount of heat is required, which is difficult to give by gas welding process. Then the arc welding is better for that. A crowded group of gas pores in the weld bead. Just see if the welding is done here. Actually, this defect mostly I am teaching in the casting chapter, and here the small in that gap, here the crowded the small particles is there, some pores are there, number of small particles are in here, then we can say this is a porosity. A crowded group of gas pores, small pores is forming because of air, that is known as what? Porosity. And if the larger size is here, you can see that I just kept here dots, and if the large hole is forming here, then that large hole, it is looking more large, it is not that large, little bit smaller, then we can say it is as blowhole. Next, in which method the filler metal is distributed in the joint surface by the capillary effect? Out of this method, just see the options: soldering, brazing, braze welding, all the above. This is the case of brazing. This is the case of braze welding. Braze welding. In which method? Here the gap between the two plates is very small, small gap. And if the water or molten metal is entering into the small gap, then that metal has high capillary action. Then what they are saying? Capillary effect, where the capillary effect is important in the brazing or braze welding. In the braze welding this gap is very big, but in the brazing this gap is very, very small. And molten metal must enter into that small gap, and that is known as capillary effect. And the capillary effect is most helpful in brazing. Then I am writing the answer, option B is correct. Next question. Which of the following welding is automated? Automation where it is possible. Guys, automation is possible in metal inert gas welding, MIG, as well as submerged arc welding. Automation is possible in metal inert gas welding. Means automatic welding will go on. No need to go and wait for welder there. Complete automation is there. Once switch on the machine, the work will complete, the welding will complete. And that 100% automation is possible in metal inert gas welding or submerged arc welding. What about shielded metal arc welding? Very old, not possible. Gas tungsten arc welding. Full automation is not possible. Gas tungsten arc welding, 100% automation is not possible, but somewhat semi-automatic, I can say semi-automatic. Semi-automatic we can say. But oxy-fuel gas welding, this is gas welding, not possible. Answer is MIG, as well as we can use the submerged arc welding. Pillar rod in brazing is made up of BRA, ZING. What is written here? ZIN. Where is ZIN here? What is the correct answer? Option A. In a brazing, the filler rod is made up of copper zinc. In a braze welding, the filler rod is made up of copper tin. In a soft soldering, the filler rod is made up of lead tin. And if you want high strength soldering, then it is known as hard soldering. And where that hard soldering is possible, in the lead tin silver, soft soldering, add silver, hard soldering. Then filler rod in brazing is made up of copper zinc. The filler rod in braze welding made up of copper tin, soft soldering, lead tin, hard soldering, lead tin, silver. Next question. 15 questions. Here all the welding questions are over, guys. Now what is remaining? We have the 15 minutes of time and 15 casting questions. We have to see very easy questions are there. Very nice questions are there, the casting questions. Right? Now we'll start with the casting question, but I want here your replies. Very good. Yes. Now see the first casting question here. Here also I want to tell you some important concept. Just see the first casting question here. Give the answer. Right. Yes. How many stages of cooling in casting? The total, the 3 stages of cooling in casting, very important, and for some student it is confusing. I want to tell you how it is. You can see here, this is the stage 1 of cooling, this is the stage 2 of cooling, this is the stage 3 of cooling. Very important diagram there, maybe the question in exam. First stage, second stage, third stage of cooling. In the first stage, you can see here the temperature is what? Here the powering is temperature. Here the temperature is freezing temperature. Here the temperature is room temperature. Here the powering temperature as a liquid. here the temperature, pouring temperature, here the temperature is freezing temperature is a liquid, here the solid, here the solid. Yes, means we are pouring temperature means at this temperature we are pouring the molten metal. Then here the liquid will be there, and from here to here the liquid will start converting into solid, and here we will get the solid. Means where we are obtaining the solid, freezing temperature as a solid, we can say. Here also we can get the solid, but here the temperature is 25 or 26 degrees centigrade, room temperature solid. These are two stages are there. The stage 1 and stage 2, what is going to shrink, liquid or solid? Tell me, very, very important. In the stage 1 and stage 2, who is converting into solid, liquid or solid is in converting into solid, means solid remains solid or liquid is converting into solid. In stage 1 and 2, the liquid is converting into solid, hence it is known as liquid shrinkage. First two stages, liquid shrinkage, very, very important. Many students are facing confusion here, liquid shrinkage, and stage 3 is known as solid shrinkage. Solid shrinkage. Liquid shrinkage, the pouring temperature is a liquid to the freezing temperature as a solid. This is known as liquid shrinkage, right? Now see next question. Out of metal which is having highest total shrinkage. What is mean by total shrinkage? From the diagram you can see that total shrinkage is liquid shrinkage plus solid shrinkage. In which material the total shrinkage is highest? In the steel material the total shrinkage is highest. Very important guys, very important. Then tell me in which case the liquid shrinkage is highest. In which case liquid shrinkage is highest? In aluminium the liquid shrinkage is highest. Liquid shrinkage is high in aluminium. Solid shrinkage is highest for which material? Brass. Solid shrinkage SS high for the brass, but total shrinkage is highest for the steel. Very important. Which of the following allowance is negative allowance? Wrapping allowance is also known as shaking allowance or shake allowance. Wrapping allowance is negative allowance, is shake allowance. Guys, there are total 5 allowances are there. The first allowance is shrinkage allowance. Second allowance is machining allowance. The third allowance is a draft allowance. Fourth allowance is this wrapping or shake allowance. Yes, and fifth is distortion allowance. Distortion allowance. Out of that all allowance, only the shake allowance is negative. Only this is negative, all are the positive allowances. Very important question. Next, the recess or open space provided in the mold for positioning, locating and supporting the core is called as. Now here in the diagram we have to place the core. Where we can place the core? We can place the core like that. Here we can place the core. Here we can place the core. But where we are placing the core? Just see, here we have to place the core. But where we are placing? Here, and that is known as core print. This is known as core print. In the core print we can place the core. And what is the question? The recess or open space, you can see it here. This is the recess or open space. This is the open space in which the core can sit. Just see the core, I can show like that. The core can sit here. The core can sit here. The core can sit here. And in the open space, or also we can use the word recess, and that is known as core print. Then you can see what is the option here. Core print, this. Chop plates, chills, padding, some different parameters. Core print is the correct answer. Basic function of pad. You can see the pads are there. These two pads are there, and here you can see the pattern. We have to remove the pattern here with the help of spike. Remove the pattern with the help of spike. When the pattern is removed, here you will get the empty space. In that empty space, we can use the word cavity. That cavity is also known as casting cavity. In that casting cavity, we have to pour the molten metal, and that molten metal does not have a contact with this corner portion. Here if you pour the molten metal, then that molten metal does not have a contact with this corner portion. Yes, and in the corner portion some loose sand particles are present. If these two pads are not there, then that in the corner portion some loose sand may be there. then loose sand can enter into that molten metal, and when that molten metal is converting into solid, then we will get the defect, sand inclusion defect, sand inclusion defect. We will get the defect sand inclusion. That's why we need to use the pad. Then what is the basic function of pad? Basic function of pad to avoid the sand erosion. Yes, this is the 100% correct answer. But in the same references, they are also telling that provides directional solidification. What is mean by directional solidification? Directional solidification means when we are pouring the molten metal, then that pads are extracting the heat, the pads are absorbing the heat, the pads are absorbing the heat, and the pads are trying to cool that molten metal. It is also happening, but the percentage is very less. But it is also happening, and because of that I want to write the correct answer as of both, so option A and B, to avoid sand erosion as well as provides the directional solidification. Splash core is provided at the bottom of the sprue. We can see that this is the splash core. When the molten metal is entering here, when the molten metal is entering here, then it is going to hit it here, and then it is going to turn by 90 degree. When the molten metal is coming with very high velocity, and when it is giving the force here, if we are using we are not using the splash core, just remove the splash core from here. If the splash core is not there, then the sand is there. Then what happen? These molten metal will give the high force on the sand. It is coming with the high velocity. High velocity, when the high velocity molten metal will strike to this part, then that high velocity will convert into impact energy. Then there will be the erosion of sand particle. Erosion of sand particle means sand particle will come out from there, and it will enter into the molten metal, which will give the sand inclusion defect. And that's why we are using here the splash core, and which is also made by ceramic material, like our basin at our home, same splash core. And because of that splash core, then what happened? It can avoid the sand erosion, and correct option, option D. Sand erosion, it can avoid sand erosion, no any other option. Correct option, option D. Yes? Yes. Now next question. Getting ratio for non-pressurized, very big topic, pressurized getting system and non-pressurized getting system. Yes, remember that all the ratios they can ask in exam. Here the correct answer is 1:3:3. In a non-pressurized getting system, you can see that gating ratio. What is the gating ratio here? Gating ratio is area of a sprue as to area of runner as to area of ingate. Then that ratio is going to increase in the non-pressurized getting system, and here you can see that it is going to increase, hence correct option is 1:3:3. Next, solidification is a time taken to cool the molten metal from pouring temperature as a liquid to. Solidification means what? It is denoted by tau. This is known as solidification, or we can say the solidification time. This is known as solidification time. Solidification time. The solidification is a time taken to cool the molten metal from pouring temperature as a liquid. Where is pouring temperature as a liquid? This is the pouring temperature as a liquid. This is the pouring temperature as a liquid. Up to what? This liquid, this solid, this is known as freezing temperature. Very important. Very important. Very important. Yes, you see here. This is what? Liquid solid. Then the solidification time is from this point to this point. This is stage 1 of cooling, stage 2 of cooling, stage 3 of cooling. We can write here the point A point, here the B point, here the C point we can write, and here finally the D point we can write. The solidification time is pouring temperature as a liquid to the freezing temperature as a solid. Where is the option? Pouring temperature as a liquid to freezing temperature as a solid. Where it is freezing temperature as a solid? Correct. It is not room temperature as a solid. Where is room temperature as a solid? This is the room temperature. This is the room temperature. It is not correct answer. Option B is correct. Next question. solidification is inversely proportional to, solidification means solidification time. There is formula, the solidification time is equal to, I can write the formula for solidification time. Tau is directly proportional to, first I want to directly proportional to the ms square. Then the tau is equal to ms square K1. What is capital M? Mold modulus. Then what is that mold modulus? Volume by surface area whole square into K. Then we can say that solidification is directly proportional to V by S. This K is solidification constant, V is the volume, S is surface area of casting losing heat. Not only surface area of casting, surface area of casting losing heat. If just see this is the casting, we have to make this metal by casting method. Then volume by surface area, tau is equal to volume by surface area whole square into K1. What is the surface area losing heat? How many surfaces? 1, 2, 3, 4, 5, 6. If out of 6 the top surface is not losing heat, how many surface? 5. Only we have to add the 5. Surface area is not 6, very important. Yes, and here solidification is inversely proportional to the surface area. Yes, surface area losing heat, surface area losing heat is the correct answer, option D. Mold modulus means what? Capital M. The solidification time is directly proportional to mold modulus. Mold constant is K1, it is directly proportional to mold constant K1. Yes. Then volume directly proportional to and surface area is correct. 10 question. For minimum heat transfer from the riser, the best preferable shape is, means which is the best shape of riser? Best shape of riser. We can use the cylindrical, best shape as the cylindrical shape we are using. The spherical is also good, but to manufacture a spherical riser is very difficult. That's why we are using the cylindrical riser only. The best preferable shape is cylindrical. Next, die casting is used for. Die casting is used for producing the simple shape of casting. There is the investment casting which can produce the complex shaped component. Investment casting which can give the complex shaped component. Die casting is no simple shaped component. In the die casting, the mold is made by metal. In the die casting, the mold is made by metal. The mold is made by metal. And if the mold is made by metal, then if we are using the high temperature casting material, then the die can melt. That's why it is always better for low melting point metals. A correct, B correct. For producing infinite number of casting, yes, this die is metal die, we are not breaking that metal die. We can use the infinite number of casting. His correct answer is option D. Then next, hot chamber die casting is used to cast. Hot chamber die casting is used to cast the number of material such as lead, tin, cadmium. Lead, tin, cadmium, zinc. We can use the lead, tin, cadmium, zinc we can use. These all the temperatures of very low melting point temperature. And we can use for hot chamber die casting. Out of that all, how many options are there? Brass, lead, aluminium. Lead is the option, hence correct is B. But if there is a cold chamber die casting, if they are asking the cold chamber die casting, that is a lead, tin, zinc, cadmium, all we can do on cold chamber die casting. And additional aluminium, copper alloys also we can use in cold chamber die casting. Now say next question. An expandable pattern. Expandable pattern means pattern is going to break. Yes, this is the pattern. This is the wax pattern in investment casting. But investment casting method is not expandable. Expand means break. Expand means break. This investment casting, very important, is not only expandable pattern process, it is also expandable mold process. There is only one and one method where the mold we are going to break, where the pattern we are going to break, only one method, and that is known as investment casting, means expandable pattern as well as expandable mold. Next question. Impurities or foreign particle present inside the casting, very easy, the dross. Impurities means some dust particle or some dust particle is there or some wood particles is there. Next question, and this is the last question. The mismatch present between the cavities of cope and drag is mismatch. You can see this is the cope, this is the drag. Yes, this is the drag cope here. And what is that? It is known as shift, or also we can say as mold shift. I hope so there is a good revision of all the three topics you need to give here. The reply, is this good session? Do you like that questions and revision? Yes, and I want to say you the thank you very much for attending this session. I am very, very happy because of your response. Thank you very much, and finally all the best for your exam. Thank you very much.